At 1:23 in the morning on April 26, 1986, Reactor 4 at Chernobyl exploded, releasing 400 times more radiation into the atmosphere than Hiroshima. Within days, the fallout had reached Sweden. Within weeks, traces were detected across Europe. 350,000 people were evacuated from 4,760 square kilometers of land, an area larger than Luxembourg, and sealed off from humanity. Scientists said it would remain uninhabitable for at least 3,000 years. 40 years later, this is one of the most wildlife-dense landscapes in all of Europe. So how did the worst nuclear disaster in history accidentally create a nature sanctuary? The answer starts with the land itself. The exclusion zone doesn't belong to one country. It straddles the border between Ukraine and Belarus, a flat expanse of Polesian marshland, mixed forests, and river systems. The Pripyat River runs straight through the zone and feeds into the Dnieper, which supplies drinking water to Kiev. Before the disaster, this land was already ecologically rich. Ukraine controls 2,600 square kilometers of the zone, now designated the Chernobyl Radiation and Ecological Biosphere Reserve. Belarus controls the remaining 2,160 square kilometers as the Polesi State Radioecological Reserve. Together, they form one of the largest protected areas in all of mainland Europe. But radiation here is not a blanket, it's a patchwork. The Red Forest, a 10 square kilometer zone immediately surrounding the reactor, remains the most contaminated place in the exclusion zone. Move outward and the contamination drops sharply, grading from severe to moderate to levels approaching normal background radiation across most of the zone's area. Within a month of the explosion, most of the short-lived isotopes had already decayed. Within a year, the acutely dangerous immediate radiation had largely dissipated, though the long-lived contaminants, cesium-137 and strontium-90, would persist for decades, but everyone was already gone, and they would never come back. When humans left, everything else moved in. No hunting, no farming, no roads being built, no construction, no pesticides. Agricultural fields at the edges of the zone began reverting to scrubland, then forest. Prey species had no hunting pressure, and their populations exploded. Predators followed. Biodiversity cascaded upward from there. Within 10 years, wild boar, elk, and roe deer populations in the Belarusian sector had surged. Wolf density reached 7 times that of comparable uncontaminated reserves, according to a 2015 study published in Current Biology. More than 400 vertebrate species have now been documented inside the zone: 73 mammals, 251 birds, 67 fish species. Species that had largely disappeared from the surrounding region came back. European lynx, brown bears, European bison, black storks, golden eagles. Przewalski's horses, reintroduced in 1998, now number around 200 on the Ukrainian side alone, with another 50 across the border in Belarus roaming freely. The zone's position amplifies this effect. The Polesian marshlands connect northward into larger forested corridors across Belarus and beyond, making the zone a safe harbor within a wider landscape of relentless agricultural pressure. The wildlife isn't just surviving despite the radiation. In much of the zone, there are more animals than in the clean forests and farmland immediately outside it. Not every researcher agrees on what the radiation is actually doing to the animals living inside the zone. Timothy Massow at the University of South Carolina has documented real biological harm in the most contaminated areas. DNA damage, higher tumor rates, stunted reproduction in certain species, asymmetrical insects, albino barn swallows, and cataracts in voles. The red forest itself presents ongoing problems. Leaf litter there decomposes at abnormal rates, which elevates fire risk and keeps radioactive material cycling through the environment in unusual ways. But other scientists read the same data differently. Stuart Thompson, a plant biochemist, has concluded that radiation's biological burden at Chernobyl is less severe than the ecological data suggests it should be. Jim Beasley at the University of Georgia found wolf, boar, and bison populations inside the zone at densities matching or exceeding the healthiest uncontaminated reserves in Europe. Nick Beresford at the UK Centre for Ecology reviewed decades of population data and reached a blunt conclusion. The overall effect on wildlife was positive. A 2022 study in the journal Evolutionary Applications added another layer. Frogs in the exclusion zone have evolved noticeably darker pigmentation, a likely adaptation to radiation exposure. The species is not simply absorbing damage, it is responding to it. The answer is geographic as much as biological. 2/3 of the exclusion zone has radiation levels close to normal background. The animals are not concentrated in the most contaminated areas. They are spread across a zone where most of the land is ecologically functional and completely empty. This pattern forced an uncomfortable question because it repeated itself somewhere else entirely for completely different reasons. The Korean Demilitarized Zone, a strip 250 kilometers long and 4 kilometers wide, the most heavily militarized border on Earth. More than 70 years of human exclusion. Inside that strip, red-crowned cranes, Asiatic black bears, and possibly Amur leopards. One of the best preserved temperate habitats in all of Asia, created entirely by a political standoff. The Darien Gap on the Colombo-Panama border, a roughly 100-kilometer break in the Pan-American Highway where the road simply stops, too dense and too dangerous for development to proceed. Jaguars, harpy eagles, and tapirs fill the void. The Cyprus Buffer Zone, the UN-controlled green line dividing the island since 1974. More than 50 years of minimal human interference, rare orchids, endemic reptiles, and migratory birds now rely on a strip of land that only exists because two governments cannot agree on who owns it. The pattern repeats: radiation, landmines, political standoffs, different causes, identical results. The question Chernobyl forced scientists to ask is an uncomfortable one. Are we the disaster that ecosystems need to recover from? In February 2022, Russian forces drove through the exclusion zone during their invasion of Ukraine. Soldiers operated vehicles through the Red Forest, disturbing decades of accumulated contaminated soil. They occupied the zone for weeks before withdrawing. The full environmental cost of that military activity is still being assessed. In 2025, researchers found that a 100-hectare test site in the broader contamination zone, outside the exclusion boundary, could safely grow crops again. They estimate up to 20,000 hectares could follow. That is a small area against the full scale of the zone, but it signals a direction. As radiation continues to decay, pressure to redevelop the land will grow. Ukraine designated its site a biosphere reserve in 2016, which provides legal protection. But wartime priorities have a way of overriding conservation commitments. Meanwhile, solar farms have been operating inside the zone since 2018, using the old transmission infrastructure from the reactor itself. Belarus opened its site for limited wildlife tourism the same year. The United Nations Development Program has called the zone Europe's biggest rewilding experiment and has been investing in research infrastructure there. The exclusion zone sits on some of the flattest, most farmable land in Ukraine. For 40 years, radiation kept humans out. But radiation is decaying, development pressure is building, and a war has already broken through the boundary once. The question is no longer whether the sanctuary will survive. It is whether anyone will choose to protect it. The cesium is decaying. Within decades, there will be no physical barrier left, only a legal designation and political will between this sanctuary and the farmland that surrounds it on every side. Belarus's Polisi Reserve has fewer legal protections and draws far less international attention than the Ukrainian side. That asymmetry could matter a great deal in the decades ahead. For 40 years, the disaster ran an experiment no scientist would have approved. What happens when the most destructive force in an ecosystem disappears? The answer changed how we understand every ecosystem on Earth. But here is the real question this place forces us to answer. If the best thing that ever happened to this land was the worst thing that ever happened to the people on it, what does that say about how we share this planet with everything else?